quantity of heat. The caloric theory was ruled out by Sir Benjamin Thomson based on his experiments and suggested that explanation in relation with motion. He deduced the idea that mechanical work is responsible for the creation of heat. So this theory was considered equivalent to the kinetic theory of gases, one of the concepts intertwined with thermodynamics. His experiments inspired the work of Sir James Prescott Joule and other scientists towards the middle of the 19th century. Sir Joule theorized that the equivalence of heat and work as two forms of energy. This leads us to the definition of quantification of heat. So since heat energy is in transit, it is measured in joules. So since energy siya, in mechanics, we measure energy using joules, and the same unit is also followed in thermodynamics. However, a more common unit of heat is the calorie. The calorie is defined as the amount of heat required to change the temperature of 1 gram of water through 1 degree Celsius. So another unit, although not frequently used, is the British Thermal Unit, or the BTU. BTU is the abbreviation. So it is defined as the amount of heat required to change the temperature of 1 pound of water by 1 Fahrenheit degree. So, sa madaling sabi, 1 calorie is our way of quantifying heat through the metric system. Since we use gram and degree Celsius. On the other hand, the British Thermal Unit, or BTU, is the equivalent version in the English conversion system, or English units, since it uses pound and degree Fahrenheit. So there are important equivalences in values that we can remember so that we can have easier time in converting from one unit to another. So remember that 1 calorie is equals to 4.186 joules, and 1 kilocalorie, or 1 kcal, is equals to 4,186 joules. 1 BTU, or British Thermal Unit, is equals to 778 feet-pound, which is also equals to 252 calories. Ayan. So, madaling sabi, 1 BTU is equals to 252 calories. So, this is an easier way to remember when we want to convert from calorie to BTU, or vice versa. So, you've likely noticed that some foods remain hotter much longer than others do. If you remove a piece of toast from a toaster and pour hot soup into a bowl at the same time, a few minutes later, the soup is still warm while the toast has cooled off substantially. We can conclude that different substances have different capacities for storing internal energy. This also means that different materials require different quantities of heat to raise its temperature, given a certain mass of that material by a specified number of degrees. For example, 1 gram of water, or 1 GH2O, requires 1 calorie of energy to raise its temperature by 1 degrees Celsius. So, yun yung pinag-usapan natin kanina. However, it only takes about 1/8 as much as energy to raise the temperature of a gram of iron by the same amount. So, for example, if we want to heat 1 gram of iron, or of pure iron, by 1 degree Celsius, or by 1 degree centigrade, we just need 1/8 calorie. So, this is the concept of a specific heat. It is the amount of heat required to change the temperature of a certain object. Or in other words, it is the ratio of heat supplied to the corresponding rise in the temperature of the body. So this value, specific heat denoted as Q, can be determined through the formula below. So the specific heat C has different values for different materials. So M is your mass, and delta T again is your change in temperature. Change in temperature, while C is the specific heat capacity of a certain object. So, gaya ng sabi ko kanina, magkakaiba ang value ng C for every given material. So, gaya nito. So, mas makikita natin dito from the example previously that water and iron have different specific heat capacity values. Heat is introduced as a thermal energy that is absorbed or released during a change in temperature. The quantitative relationship between heat and temperature is best described by the concept of specific heat using this equation. The Q lost is equals to Q gained. So this is a simple, intuitive way to set up a conservation of energy equation. And that is to write that the heat lost by one part of the system, your Q lost, is equals to the heat gained by the other part. So this equation is particularly useful in calorimetry and other thermal equilibrium problems. So usually we use this equivalence in calorimetry problems. Thank you for listening. I hope you learned something today, and see you on the next discussion video.